This is MAP4C, day 4. This is actually lessons for sections 1.2 and 1.3. The 3-minute review is a review of yesterday where we were solving real-life problems using right-angle trig. Here we have a question. From the 10th floor, the angle of elevation of a second building 26 meters away is 65 degrees. The angle of depression of the bottom of the building is 78 degrees. How tall is the second building? In any of these questions, I think the most difficult thing is to draw a diagram. Once we get the diagram drawn, it'll be fine. So here we go. That's ground. This is building 1. Here's building 2. And then there's going to be a spot from some spot on the 10th floor. From some spot on the 10th floor, let's say here, this is the 10th floor. The angle of elevation of a second building is 65 degrees. Remember, we always start from the horizontal, right? So start from the horizontal. There's the horizontal, this person looking out towards the second building, and the angle of elevation is 65 degrees. So looking up at the top of the building, that angle there is 65 degrees. There's the horizontal, put that back in. Label that angle, that's 65 there. Then it says the angle of depression of the bottom of the building is 78 degrees. So looking down from the horizontal, this angle here is 78. And we want to find how tall the second building is. Well, it's 2 pieces, right? We got a piece in the top triangle, I'll call that X. A piece in the bottom triangle, call that Y. The 2 buildings are 26 meters away, which tells us that that length there is also 26. And so we'll be able to get this together without too much trouble. In this top triangle, we've got the opposite side and the adjacent side to the 65 degrees is 26. So opposite and adjacent, I'm going to use the tangent, is opposite over adjacent, and I can calculate x there. 26 times the tan of 65. Boom that into your calculator. 55.7. And then in the bottom triangle, same thing. Some calculator work here. Those are approximate answers. Y is 122. And then in total, I've got 55.7 plus 122.3, a total of 178 meters. That's it. Now, the lesson today is actually a little bit strange. The lesson has, don't look. First, you doing an investigation. So you should pause the video, give yourself a rating for the 3-minute review, do the investigation. Now, this might be in class, that would be fine. There'll be a lesson that follows the investigation, making sure that you got out of it what you're supposed to get out of it. And in this video, I'll be sort of just showing you the answers that you could or should have got, and then trying to make some sense of it, what type of homework questions we're supposed to get. So pause the video, do the investigation. Okay, once you've tried the investigation, here's what you should have got. I'm going to just go through it real quick. And if you have any questions about the investigation, we can talk about it in class. Remember, you can pause if I'm going too fast. Okay, so the whole thing about this investigation is that um, what's new here is that we're going to start dealing with angles that are more than 90 degrees. And it says until now we've only dealt with acute angles, and that's in until now meaning in grade 10 and grade 11. But some weird stuff happens if we try and start taking the sine of angles that are more than 90 degrees, sine and cos. And that happens when we start talking about non-right triangles. In this triangle here, if there was some way we could somehow solve this um, all at once, this angle, if I put the two together, is more than 90 degrees. And so how do we take the sine or the cos of an angle that's more than 180 degrees, or 100, sorry, more than 90 degrees rather? And that's what we're talking about today. So away we go. Back to the lesson. It says we saw in the investigation that sometimes two different angles will give us the same sine value. We want to explore why this is the case. Let's think of sine of A equals 0.5736 in a different way. Let's use a grid. And just bear with me about this. So I'm going to plot 10, 7 on this grid. 5, 6, 7, 8, 9, 10, 2, 4, 6, 7. About there. Call that point P. And then I'm going to draw A, which is the angle created between OP and the positive y-axis. So this angle right here is A. That's A. You see what we've done is we've just placed our right angle triangle on an XY grid. Now, why the heck would we want to do that? Well, that's hopefully going to solve a mystery for us. We want to calculate this angle. So notice that in this triangle, it's just a right angle triangle. This length is 10, was the x coordinate, wasn't it? And this length is 7. And so if I want to find out what A is, well, I've got the opposite side and the adjacent side. That's the tangent of A is 7 over 10. Inverse sine of that. And I get A is about 35 degrees, which is the same as the story from earlier on this sheet, right? A was 35 degrees earlier. Then it wants us to find the length of OP, also called the radius. Well, that's just the hypotenuse, so I'm going to use Pythagorean theorem here. Take the square root at the end, and you get about 12.2. And see, if this is 12.2, then we can state the other ratios as well. So state the sine of A, well, that's just opposite over hypotenuse, 7 over 12.2. This is 10 over 12.2, adjacent over hypotenuse, and the tan, like we set up there, is 7 over 10. Now, what I wanted to point out just before we start going on, if you were to clunk 7 over 12.2 into your calculator, you're going to get pretty close to this value right here. That's about the same thing as 7 over 12.2, the sine of angle A. And if I go sine of 35 degrees, sine of 35 is about that same angle. So this is all fairly familiar for us. It's a right angle triangle, and we can find the sine of an angle, or we can find side lengths, whatever we would like. What's different is if we start talking about, well, what happens if we want to find the sine of an angle that's more than 90 degrees? And we'll see how we do that next. It says repeat this for the point. Oh, hang on. A little bit of English errors. There we go. Repeat this for the point negative 10, 7. So negative 10's over here. Negative 10, and then 7, there's this new P. Notice what's strange here. This is the same triangle as above, isn't it? Exact same triangle. This is 7, but this is this length is 10. But if we talk about on the grid, this is actually negative 10, isn't it? This is still 12.2 because it's the same size triangle. And notice this angle, this is the angle A that OP makes with the positive x-axis. This is the angle A. Well, if this is 35 degrees, then A is just 180 minus 35. Does that look familiar? I hope so, because that's exactly what we were trying to get out of you from the investigation, that these two angles add up to 180. The length of OP is still 12.2. That's from earlier, same triangle. And so now the sine of A is still opposite over hypotenuse, opposite from this angle, 7. It's still 7 over 12.2. This is the same as above, but now if we think of the cos of A, the adjacent side, well, the adjacent side's negative since we went left on the grid. And the same as the tangent. We got 7 over negative 10. The cosine and the tangent are both negative. And that's kind of strange, but it's also what we saw in the investigation as well. Morals to this story. What are we supposed to get out of this? What are we supposed to what are the take-home information? Well, there's a few things. Change my color here. Well, the first of all is, maybe that's surprising to some people, is that we can take the sine cos of obtuse angles. By putting them on a grid. Them means angles, by putting the angles on a grid. Number 2, if angle A, and that's what we're talking about, them is the angle. If angle A is obtuse, remember that means more than 90, the sine of A is positive, right? And we saw that in the investigation and in this example up here, right? This was A was 145 degrees, and the sine is a positive number. However, if angle A is obtuse, the other two trig ratios, cos of A and tan of A, they're negative. The last thing, and this is really what we're worried about, because soon we're going to get into using the sine law, and when we're solving this, sine A equals some number. Remember, we had like 0.57 whatever, so point blah 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 blah, whatever this number is here, doesn't matter. Equations like this have two solutions. This equation has two solutions. One that your calculator gives you, and the other one that adds up to 180. So has two solutions that add to 180. I'm just going to check my time here and see if I need to split this into 2 videos. Yeah, I'm going to stop there, and we'll pick it up in part 2.